This is the Unit 5 study guide for Math 7 on inequalities. The first question asks you to just label simply as an inequality, expression, or as an equation. Inequalities are fairly simple. They have one of the four inequality symbols: is greater than, is less than, is greater than, or equal to, is less than, or equal to. Of course, it needs to be true, but we probably did not give you any inequalities that are not true. An expression needs to have at least one math operation. There are algebraic expressions and numerical expressions. And an equation needs to have an equal sign, needs to be, of course, true. So this is really that simple. A would be true if f were 5, so this is an equation. B has an equality symbol. We could solve this. This is an inequality. C, no equal sign, no is less than sign. It's just a bunch of math operations, multiplication, addition. This is an expression. D, 5 plus 3 equals 8 is a true math sentence. It is an equation. E, we can solve. It is an inequality. F is just a bunch of math operations, multiplication, addition, multiplication, addition. This is an expression. G is a true math sentence with one of these symbols. It's inequality. H, again, no math operations, but no comparison symbols. This is an expression. And I has an inequality symbol. It's true. Well, it's actually not true. So 15 is not greater than 15. So I wouldn't call this an inequality. I would actually call it none. Maybe a trick question, but since that's not true, I would call that none, since 15 is not greater than 15. It's greater than or equal to, if it was that, it'd be an inequality. But for me, I would say that's none. 2, A through F, asks us to translate into a mathematical inequality, so we're guaranteed to have an inequality symbol. Is greater than, is less than, is greater than or equal to, or is less than or equal to. Number 2A, 8 less than a number is greater than the square root of 9. My trick to you is to circle the word is, then you realize it's is greater than, so you know it's is greater than. The square root of 9 is simply the square root of 9. I know the square root of 9 is equal to 3, but just because the square root of 9 is equal to 3 does not mean you need to solve it. You just write the square root of 9. We're translating, not simplifying any further. All right, now we do this part. 8 less than a number, which goes on this side, is not 8 less than a number. There's that word less than, which you're guaranteed to see. It's 8 less than a number. Less than does flip the order, it switches them, but it stays on this side. That's why we circle and do that part first. B. There's the word is at most. Is at most means is less than or equal to. At most means the most it could be. So it can be equal to or it could be is less than, but it can't be greater than. So the most it could be is 4. Is at most 4. The difference of twice a number and 7. So difference means subtraction. The difference of twice a number and 7 is at most 4. Remember that twice a number is not x squared. Could you put x squared? No. C. There's my word is, but it's is at least. Is at least means is greater than or equal to, because the least it could be is 30. It could be equal to 30. It also could be greater than 30, but the least it could be is 30. So is at least 30. The sum of a number squared and 1. This is the sum of a number squared and 1. Number squared different than twice a number. D. Looking for the is greater than the square root of 2. Negative 44 less a number is negative 44 less a number. Less is different than less than. E. Is less than, so it is less than 0. Again, you circle the is and then see if there's more. The quotient of a number and 2 decreased by 5. The quotient, which means division, the quotient of a number and 2 decreased by 5. Could you do 2 divided by w minus 5? No. Could you do w divided by 2 that way minus 5 is less than 0? Yes, you could. This looks better, but this is technically also correct, because we divide and division comes before subtraction anyway, so they both would be okay. F. Is at least means is greater than or equal to, is at least 10. The product of a number and a different number. The product of a number and a different number, so the multiplication of a number, which we'll call k, times a different number, which we'll call, let's say, f. K times f is greater than or equal to 10. Question 3 says to draw a model that represents each inequality. Make sure you show the key. So let's do a key first. W will be a big, long rectangle. Let's say we need a negative W. We'll do a big long rectangle, except this time we'll fill it in. And we'll do 1 is equal to a square and negative 1 is equal to a filled in square. 3w is 3w's. Then a negative 2. 1, 2 negatives is greater than, and then we have 4 negatives. One of the ways you could do this if you want to get cute is you could sort of say that this whole thing is kind of tilted, where this side is heavier, that's why it's way down that way. Let's do this one over here. Negative 3w is 3w's, but they're negative, so they're filled in. Plus 5, 1, 2, 3, 4, 5 is less than or equal to 1, 2. Again, if you want to get cute, you can sort of tilt it, this way. Since this side's heavier, it goes down more. But, alas, let's just straighten them out. That one could probably be straight also. 4. Says to work backward, write the inequality that's written on the lines below. Since this is filled in, we know there's a line underneath. No line underneath. Either way, we know our starting number. In this case, it's negative 6, and let's put a variable w. This one is 6, and let's put our w. This one is 3, and I'll put a w. Now I know this is filled in, so there's a line underneath. Open, so no line underneath. Open, so no line underneath. All right. Since we're shading in the smaller direction, that means W must be on the small side of the inequality. All inequalities have a big side and a small side. This is a small opening, this is a big opening. Equal signs have equal length openings. Like this opening is the same as that opening. In an inequality, this opening is much bigger than that opening. That's why W is on the small opening, which means since we're graphing W, that's where the small numbers are. Same thing here, except W, we're going to the big side. We want W on the big side of the inequality. W is greater than 3. And then on this one, we're shading the smaller numbers, which means W must be smaller. We're shading, we put W on the small side of the inequality. All right, the rest of them ask us to solve and then graph. Note that we have to solve before we graph. I have seen students in the past make the mistake when they try to graph it right away. You can't graph it until you're ready to solve it. It's just like solving an equation. Figure out what was done, undo that. Subtract 4, we get m. 7 minus 4 is 3. Make sure you bring down the symbol. If you put no symbol, and you just do this, we're going to have to mark it incorrect because we don't know if you put an equal sign, it is less than, it is greater than, did you put a line underneath? You need to put the actual sign, otherwise we're going to have to take off points. So m is less than 3. I go to 3, open circle, less ink means less ink. Since m is on the small side, we shade to the smaller numbers, which is to the left. 5. Split it. Add 15 to solve, add 15 to solve. We get D, negative 5. Make sure you put a symbol between them, circle your answers. We go to negative 5. Open or close circle. Well, since there's no line underneath, it's open. Less ink means less ink. And since D is on the big side of this symbol, again, this is the big side, that's the small side. D is definitely on the big side. We shade to the bigger numbers. 6. Split down the middle. Divide by negative 3. We're not going to add 3. We undo multiplication with division. We get F, negative 7. And this is one of the main reasons why we have to put a symbol, because when you divide by negative, the symbol has to flip, and we need to know that you flipped this symbol to the opposite way. We go to negative 7. Remember, the symbol flips only when you multiply or divide, in this case, by a negative. Since I divided by a negative, the symbol flips. Open circle. F is on the big side, so I shade to the bigger numbers to the right. Bigger numbers are always to the right. Split it. We'll do a different color. Split it. Multiply by 2. Multiply by 2. We get W, negative 6. Does the symbol flip? No. It only flips when you multiply or divide by a negative. Since I already had the negative and I multiplied by a positive, it does not flip. Since I multiplied by a positive, it stays the same. So I go to negative 6. This time more ink means more ink. W is on the big side, so I shade to the bigger numbers. 8 is back to a one-step with subtraction now. We undo subtraction with addition, add 3, add 3. We get D, 7, don't forget to put your symbol, which is still is greater than. We go to 7, open circle, less ink means less ink. Since D is on the big side, we shade to the bigger numbers. 9, probably the hardest question, really good question. Split it down the middle, We have a negative sign on the outside and 2 on the denominator. So it looks super confusing, but you could just consider this a negative 2. How do I get rid of this negative 2? Well, I would do the opposite of the negative 2, which is multiply by negative 2. That would cancel out both of those things. So I can multiply by negative 2 there also. Again, this negative takes care of that negative. This 2 takes care of that 2, so they're both gone. And I just have A. On the right-hand side, 1 times 2 is 2. Negative times negative is a positive. And then the other thing to consider is since I multiply by a negative, I introduce this negative. This symbol now flips. I get A is less than or equal to 2. I go to 2. Close circle, because more ink means more ink. We're shading what it could be. It could equal 2. Since A is on the small side, we shade to the small number. Small side, big side. A is on the small side, 2 is on the big side. We're shading what A could be, so it's the small side, shade to the left. Okay? Split down the middle, divide by negative 6, divide by negative 6. We get F, negative 4, and yes, I divided by a negative, so the symbol flips. I go to negative 4, F is on the big side, so I shade to the big numbers. And 11, split down the middle, subtract the 20 away. 15 minus 20 is negative 5. Got on over with integers. It's P. Should the symbol flip? The answer is no, it should not. The symbol stays the same. This is why you need to know small side, big side, because if you see this, you might consider that the arrow goes that way. And it doesn't. First of all, we go to negative 5, open circle. And since P is on the small side, here's the symbol again. P is on the small side. Negative 5 is on the big side. We're graphing what P could be. P is on the small side. We shade to the smaller number, which is always to the left. The last problem, the word problem. It says to create, solve, and graph an inequality for the situation below. Show all steps. Then we're going to graph a solution on the number line. My turtle speed, which we'll call S, increased by, oh, there's the word is. I should have circled it. Is at most. So is less than or equal to 5. Is at most 5. So the turtle speed increased by 3 is at most 5. So S plus 3 is greater than, sorry, is less than or equal to 5. Write an inequality. Create. That's step 1. Solve. S plus 3 is less than or equal to 5. The sum of my turtle speed and 3 is at most 5. Split it. Minus 3, minus 3. You get S. 2. The symbol does not flip. So I graph this. So I solved it. Now I graph it. We go to 2. Close circle. And since it is less than, I go like this. My arrow goes forever. Here's the issue, though. Are there any values in your solution that does not make sense? Well, I know that all of these are solutions. Therefore, 2 is a solution. 1.9, 1.8, 1.5, 1, 1 half, 0.1, 0, negative 1, negative. These are all solutions. That's why I'm graphing that way. Well, think about what we graphed. This solution represents S, which is my turtle speed. Do you think your turtle speed could be negative 3 miles per hour, for example? It can't. So are there any numbers that don't make sense? Yes. All negative numbers wouldn't make sense because you can't have negative speed. So technically this graph shouldn't actually go this way. It actually should stop at 0. Could your turtle speed be 0 miles per hour? Yes, it actually could. But if your turtle speed could not be 0 miles per hour, and it would have to be higher than 0, then you go like that. You would not include that spot. Well, let's say it is, and you want to have it closed in for 0. But technically, this S is less than or equal to negative 2. That would be that one.